Welcome to MCP Mesh, an enterprise-grade distributed service mesh designed specifically for AI agents. Whether you're building with Claude, GPT, or any other LLM, MCP Mesh gives you a production-ready foundation that's Kubernetes Native, requires zero boilerplate, and scales from your laptop to the cloud. Let's talk about the problem with current AI agent frameworks. Most frameworks run agents in process. Everything lives in a single monolithic application. If one agent crashes, your entire system goes down. They weren't designed for distributed environments. Try running agents across multiple machines or containers. You'll quickly hit walls. Production scaling is an afterthought. These frameworks work great for demos, but when you need to handle real traffic, you're on your own. You have to manually wire agents together. Every connection, every dependency, it's all boilerplate code you have to write and maintain. And there's no built-in observability. Want to know what your agents are doing? You'll need to pay for expensive third-party tools or build your own monitoring from scratch. So what is MCP Mesh? Here's the core philosophy. Other frameworks apply pre-LLM thinking to AI agents, deterministic wiring, central orchestration, treating them like dumb processes. But agents aren't dumb, they're intelligent. MCP Mesh creates an environment where agents discover collaborators on their own, adapt to failures automatically, and self-organize without a central controller micromanaging every interaction. Now, this doesn't mean agents go rogue. You still have full control. Instead of hard-coded if-else logic and tight coupling, MCP Mesh uses intelligent tags and semantic versioning. You get the same deterministic behavior, but through declarative configuration, not brittle code. Feature-wise, MCP Mesh has everything you'd expect from mature frameworks. But here's what sets it apart. It's built on MCP, the Model Context Protocol. This is the most widely adopted standard for AI agent communication. What does that mean for you? You can create new agents from scratch with simple Python decorators. You can port your existing agents to MCP Mesh with minimal changes. Or you can call MCP Mesh agents directly from any existing MCP-compatible tool, Claude Desktop, Cursor, or your own applications. The ecosystem is already there. Let's dive into the key features that make MCP Mesh powerful. First, auto-discovery. Agents publish their capabilities as MCP tools, each tagged with metadata and semantic versions. Other agents simply declare what capabilities they need, not which specific agent to call. There's no direct coupling. At runtime, the mesh finds the best match. If multiple agents offer the same capability, the mesh picks the right one based on tags and versions. This means your agents automatically get upgraded tools when better ones come online, and seamlessly fall back to alternatives if one goes down. Next, dependency injection. You don't wire agents together manually. Just declare what you need, and the mesh injects the right collaborators at runtime. Your agent code stays clean and focused. Graceful degradation is built in, and here's where it gets interesting. There's no single point of failure in MCP Mesh. Agent calls go directly between agents. They're not proxied through the registry. So even a registry outage doesn't affect running agents. Now let's talk about provider failover. Say you have both Claude and OpenAI available, both tagged as LLM, but Claude has an additional Claude tag. Your agent declares a dependency like LLM with a plus Claude preference. Claude is always used when available, not randomly picked. But if Claude goes down, the mesh automatically fails over to OpenAI. Deterministic preference with automatic failover. Try doing that with hard-coded logic. Built-in observability comes free with Grafana dashboards and Tempo for distributed tracing. See exactly what your agents are doing without paying for expensive monitoring tools. Kubernetes Native support means you deploy with standard Helm charts. No custom operators, no complex configurations. And LLM Provider Integration. This is where we went all in. It's not just zero-code access to Claude, GPT, and other models. Available tools from the mesh are automatically injected into your LLM context. System prompts are dynamically built from your agent's context. When the LLM makes tool calls, the mesh handles the iteration loop automatically. Call, response, call again, until done. And here's a nice convenience. Just declare your Python return type. Want a simple string from the LLM? Return a string. Need a complex analysis report? Define a pedantic type and use it as your return type. The mesh automatically adjusts the system prompt or uses structured response methods to get the output exactly how you want it. You focus on your agent's logic. The mesh handles all the LLM plumbing. Compare this to traditional frameworks. They give you monolithic deployments, manual agent wiring, complex abstractions, paid observability, and a steep learning curve. MCP Mesh flips this entirely. Distributed microservices, automatic discovery, simple Python decorators, free monitoring, and native MCP protocol support out of the box. Here's the architecture, and there's a key design decision to understand. In MCP Mesh, everything is an MCP tool, a simple function that returns the date, MCP tool, an LLM agent that reasons and plans, MCP tool, an LLM provider that talks to Claude or GPT, also an MCP tool. Why does this matter? Because everything becomes a first-class citizen in the mesh. There's no artificial hierarchy. A regular tool can call an LLM agent. An LLM agent can call other LLM agents. The boundaries disappear, and you get true composability. Now, here's something critical about how agents communicate. The registry is only used for discovery, finding who offers what capabilities. Once agents are wired together, they talk directly to each other using MCP protocol. No proxying through a central component. This means if the registry goes down, agents that are already connected keep working normally. Even if an agent starts up without the registry, it can work standalone. It just won't discover new collaborators until the registry comes back. This is true resilience by design. Redis handles PubSub for real-time updates. Observability flows automatically to Grafana and Tempo. Every agent runs as an independent, scalable service. Clean, uniform, and infinitely flexible. Now here's something we're really proud of: the developer experience. We didn't just solve deployment. We obsessed over making development delightful. Your code is production ready from day one. Run meshctl scaffold, and you don't just get agent code, you get a Docker file. You get Helm values. Everything you need to go from laptop to Kubernetes is generated automatically. Want to see what's running? Meshctl list shows all your agents. Meshctl status shows the wiring, who's connected to whom. This is your local observability, complementing the Grafana stack in production. And here's the magic for AI-assisted development. Just ask your favorite AI coding assistant, Claude Code, Cursor, or any other, to run meshctl help. It can automatically learn MCP Mesh, scaffold your agents, wire them together, and deploy all the way to Kubernetes. No Googling. No digging through documentation sites. The AI has everything it needs to build your entire agent system from scratch. Ready to build production-grade AI agent systems? Get started in seconds. Run npm install-g at mcpmesh/kli. Then meshctl scaffold -- help to see your options. Your first agent is minutes away. MCP Mesh is fully open source under the MIT license. Check out the GitHub repo, star it if you find it useful, and join us in building the future of distributed AI agents.